while we are all business people and want to think rationally, the greatest technologies always happen when people ignore ROI.
Welcome to Orbit, the HG podcast series, where we speak to leaders from across the tech ecosystem to hear how they've built and scaled some of the most successful software companies in the world.
Well, Raghu, thank you so much for joining us here. It's, I think, a great pleasure that we get to spend a little time facilitating a conversation. I'll give a little bit of background, so I'll brag on him so he doesn't have to. Raghu is a physicist, an engineer, a business leader who spent 25 years, since grad school, focusing on different ways of innovation. You spent time early at Netscape, starting in '98 during the internet boom, which we're all familiar with. Spent time at Bang Networks doing real-time network development, kind of really trying to bring the internet to a much faster pace use. And then in 2003 started your journey at VMware, which I'm sure everyone's generally familiar with VMware. We joined when there was less than 200 employees. And then your journey there over 2 decades started in product with Hypervisor, but really grew the business to, I think, correct me if I get this wrong, to the sale of Broadcom, $13 billion in revenue, roughly $4 billion in cash flow, 38,000 employees sitting in 60 countries. And so an enormous scale. And so as we talk about what we're talking about here, and the exit the Broadcom, I guess there's 2 things in there interesting. One is, I think at signing it was just short of $70 billion.
Yep.
And then you had a very long approval process.
Correct.
Which meant that you got to exit at about $85 billion. So
That's right.
It's the one time a long regulatory process paid off.
Yeah, exactly.
By $15 billion. I wish we could all say that about long regulatory processes.
Yeah.
And so when I look at this, I think there's 2, we can talk about a bunch of things, but I think there's 2 really big dimensions that I think are useful. One is, a quarter century of participating and leading innovation in a few of these changes, particularly with what happened with, frankly, virtualization that VMware
of course.
Drove, and then what we're seeing with AI today. And then second is running an enterprise that was a very big consumer of these things all along the way.
Yeah.
So I think we'll get to that. I do want to start something a little more personal. I'd love to start with just a little bit about something you had maybe even from your childhood that really has leveraged who you are today. I know.
Yeah. He warned me that he was going to ask this question. I still don't have an answer to that.
Okay.
But actually, I was reflecting on it. I grew up in the 70s and the 80s in India. And in India at the time, technologies came late. And in the 70s, if you remember, that was the age of all the lunar missions in space and all the Apollo stuff and Soyuz and Space Lab, et cetera, et cetera. So very early on, that sparked my interest in science and technology. And believe it or not, even TV came to India very late. And in the early days of, I still vividly remember when the Munich Olympics was going on. I was in middle school or something, primary school. We had to go somewhere to someplace common to go watch it. So this whole fascination with technology for me started there, right? And it's continued in. And then in the 80s, we had the advent of the PCs and the microprocessors and so on and so forth. And so that's really the formative experiences of my life that led to technology. So it still stays. In fact, a couple of days ago, just before boarding the plane, I downloaded the new book by Ashley Vance. I don't know if anybody's read it already. If they've read it, don't tell me. It's When the Heavens Went for Sale. It's a story of how space is getting commercialized.
Okay.
So yeah.
Another frontier.
Frontier.
David covered space earlier. His long job description included space, and I was like, that is a lot to cover. So the other thing I thought would be useful touching on before diving into some specifics would be, getting to Netscape early, and then frankly even the innovative work you're doing at Bang. What do you look back on at that and say, hey, what's the analogous lessons that you think you're applying today to the AI revolution?
Yeah, I mean there are some commonalities, but fundamentally these are 2 very different things in my opinion.
Yep.
I mean, the commonality, of course, is a use case that even a middle schooler anywhere in the world could understand and appreciate and get excited about, right? And so when these things happen, enormous amounts of money pour in, right? And people start using it without regard to things like ROI, et cetera, et cetera. While we are all business people and want to think rationally, the greatest technologies always happen when people ignore ROI, because in the early stages, there's so many other things that make it difficult to realize that. I think that property exists in both, right? In the early internet age as well as this. And when these things happen, there is usually a lot of overbuilding that happens, and then there is a boom and bust and cycle before things get to normal, right? Or things get to significant value creation. So I would say those are probably the similarities, but fundamentally these are two different, very different things. The internet is, as the name suggests, it's a network, right? Whereas the AI phenomenon is a computing phenomenon, right? So if you think about AI, I mean, at least the modern excitement rests on two things. One is NVIDIA creating a computer, basically, that's really good at linear algebra, right? If you think about it. It can do, what can it do well? It can do vector operations well, right? And it can do matrix multiplications and matrix operations well, right? So it lends itself to these high dimensionality problems where in order to represent something, you have to use a lot of dimensions. And then the second thing is there is an algorithm that came about in 2017 which uses that linear algebra processor to say, if you give me a sequence of observations, there is a very, very high likelihood that I'll predict the next set of sequences in that, at least for human data. We don't know how it applies to climate data and all those sort of things, natural data. So fundamentally, this is a computer and an algorithm that uses a computer, whereas the internet was a set of network protocols, and inherently it had the network effect property in it, right? And when you had a network device that was ubiquitous that got attached to it, which was the mobile, then the whole world took off. So I think the economics of distribution, the economics of access, the economics of value creation, I think will be very, very different. So when people get carried away by saying, hey, this happened in the internet, this is going to happen with AI, I sort of wince a little bit, because if you look at it from a first principles point of view, these seem to be very, very different things. Having said that, both are going to be tremendous transformers of productivity at large in the world, so there's no question about that. But for all of us that are in the business of building and operating companies or in investing companies, I think you have to look at it slightly differently.
That's super interesting. And then, so what does that mean for over the last kind of 12, 15 months you're doing at VMware, both internally and externally? How did you apply that to what you're going to do for your business and your customers?
Yeah, firstly, because this is a computing phenomenon, right? And we are in the computing business. So we took that very early, very seriously, right? And said, how do we have, if you think about virtualization, virtualization is a resource management technology at its core, and an infrastructure management technology secondarily, right? And thirdly, an enabler of elastic computing, right? So we said, I mean, that's the foundation of cloud, right? So we said, how can we apply all of these to this new form of computing instead of CPU, instead of GPU? I mean, GPU instead of CPU. And by the way, the GPU is super expensive, right? So today, if you had a hoster and you wanted to stand up a GPU and deliver it to end users, it costs you about $2 an hour, right? If you take the computing costs and power and cooling, everything, et cetera. If you're a CPU hoster, it probably costs you like between 5 and 10 cents an hour. So it's a massive difference. So there is a significant impetus for us to say, how do we make this a lot more easier and more manageable and so on and so forth. And so that was the first set of, by the way, to my earlier point, I don't think this is going to become a worldwide technology unless the economics changes. And the good news is it is changing, but it's got to change even faster. So that was the first thing that we did. And because we were serving large regulated enterprises and governments and defense, that was who was constituted 60% of our revenue. So we said, let's apply it in their domain, because for them, 70% of their data was still inside of their data centers. So that led us to pivot and create a new category of computing that we call private AI, which is now shipping under Broadcom, and it's off to a really fast start. So that was one. The second was, because this property of being able to predict linear sequences really well, right? We said, okay, where can we apply it? And the first thing we started was code. And in most companies, software development, that's probably your most expensive resource, certainly for software companies in the audience. So that's where we applied it. And then the other interesting observation as we applied it was, almost everything in a software company is tied to code. You think about it. All of your marketing, data sheets, and white papers and everything is really about what the code is doing, right? What your professional services organization is going and bidding with the customers, statement of work, is really about what the code is doing. What the sales engineer is presenting is also really about what the code is doing, right? So once you had one, we found that you could very easily start generating all of these things. So we started creating internal enterprise language model-based infrastructures, if you will, that could spit out, based on the code, start to say, okay, here is how we will create content for these sort of things and start to help these various functions. That was the second thing that we did. And the third thing that we did was this, what Microsoft has popularized now is the co-pilot kind of a model. When you have a lot of proprietary data yourself, or when your tool controls a lot of proprietary data, in our case, our customer was the data center administrator and the security administrator and so on. We had like 15 years of data on how they wanted to administer data centers and manage data centers. So we could take that, all the data that we had in the 15 years of help desk requests and so on and so forth that came from customers' knowledge bases. And then we downloaded some models from Hugging Face, and then we constructed a whole new thing that we sold as an adjunct to our management products. So those are the three ways by which we did it. How did we pivot? How could we use this to open up a new market? How does it make our existing products better? And how do we transform our internal operations?
Well, that's great. I think it's great because it's a microcosm of what everyone's wrestling with. And so maybe we hit a few of those. So on your internal operations, maybe give a little bit of a sense of what you started with and kind of your rough view, what we talked about this morning, on impact.
Yeah, I mean, I think, so by the way, a lot of what we did was within the first year of when ChatGPT became public, because we had started working on encoding models slightly even before that. Because Transformer, like we said, has been around since 2017. So we did some forward projections. So if you think about VMware as a company, we were $13.5 billion in revenue, about $10 billion of OpEx, 9 point something, out of which roughly 35% was sales and marketing, 20% is R&D, right? Cost of goods, including support and professional services, and the cost of computing, cloud computing, was about 15% and G&A was about 5%. We figured we could take a sizable chunk out of sales and marketing, reduce it from 35 to around 30, reduce our R&D from about 20 to maybe 17 or so, reduce our cost of, improve our gross margin by about 2-3 points. So you will very quickly come to about 10 percentage points of your OpEx improvement, overall P&L improvement. And for VMware, that would have translated roughly to about $1 billion, right? $1 billion. So it was tremendous. We certainly, and the line of sight to doing that did not involve, obviously we would have had to do some reduction of employment workforce and so on and so forth. But beyond that, it was not super disruptive, right? So it is very achievable. I don't know what the equation would be for companies that are in this audience, but some model like that you can pretty easily apply, especially if you're based on software.
Yeah, I thought it was super interesting given how early you started on that. And then it just really just says Broadcom got a screaming deal.
They got a screaming deal in many ways, but yes, yeah.
And then second,
by the way, I'm still an advisor to Hawk. And Hawk is not a technology, Hawk Town CEO. He doesn't lead with, so he waits for the technology to get proven. So this is not the first lever he's trying to pull. He's trying to pull other levers.
Got it.
Yeah.
And then I do want to hit the other two. And so if you talk about potentially your data center product, I think I'd love to hear a little bit about what you're thinking about the commercialization. How do you weave it in? I think that seems relatively straightforward. And then thoughts on pricing. I mean, I think this kind of gets to what a lot of people are wrestling with.
Yeah, I mean, I think we had two things in the data center. One was, like I said, our infrastructure foundation. That was, we could apply conventional economic value added to that, right? If you needed, for want of a better, 100 GPUs to do something now, you could do either a lot more with those 100 GPUs, or potentially we could let you do it with some 75 GPUs or whatever, right? So you can apply a simple economic rationale to that. And by the way, the other big value proposition for these regulated companies, especially because so much of their data was on-prem, still they have trouble. They're moving it, but they're moving it so slowly. Waiting for them they didn't want to wait to move all of the data to the cloud first, put it into a data lake, blah, 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 and then do AI. They said, hey, can we do some use cases on-prem, right? So a lot of the internal use cases where the users were employees, they get started on. So there's a very clear portion of value creation of which we said we'll take a portion. The trickier one was the equivalent of the Copilot, right? Where the puts and takes are, hey, do you just use it to get greater stickiness on your existing products and get upsells and so on and so forth? Or do you distinctly value this? And we ended up using it primarily, except in one case, to treat it as an upsell on an existing product line. And in our case, the pricing was based on CPUs under management or data center infrastructure under management. So it was independent of the number of users that somebody else brought up in an earlier session. But I've seen some companies struggle with that too, because it dramatically cuts down, especially in customer success and all those domains. That could be a pretty big challenge.
Yeah, moving away from seats on that front seems super important for where you guys.
I mean, the other big thing that I would touch upon in our journey, it was all very early, by the way. In the earlier discussion, people are saying, hey, there is an LLM, and then there is application, et cetera. There is a big temptation for all of us, especially those of us that have been in the industry for a while, to jump to a architecture and a stack view very, very quickly, right? I don't know what the end answer is here, but I don't think that stack is the right way to look at it.
Okay.
Because if you think about the most interesting applications that are consumer-facing today, they all have proprietary LLMs, right? And when I say proprietary LLMs, it doesn't mean they've started with the whole foundation, right? Take one of my favorite examples, character AI. I don't know if anybody's tried it here. So this is the one that you can actually have conversations with the characters, historical characters. You can have a chat with Julius Caesar or somebody, right? Or you can create your own characters, etc. They started with foundational models, but they've constructed something that's very unique to them. Replit, which is the IDE, core IDE tool, they've constructed something that's very unique to them. So I do believe that what is an application and what is a language model is not going to be very distinct.
Okay.
And then if you look at this age of multimodal models where you're interacting with voice and video and this and that and the other, conventional applications cannot handle that, right? I mean, our conventional applications are form-based or whatever. So I do think UI will fundamentally change, applications will fundamentally change, and they will be more intrinsically tied to language models. And language models themselves, these days you can have smaller models, right? There are techniques called distillation and so on and so forth, where you now can execute inference on these models in fairly restricted compute environments. So I think fundamentally the application stack will change, and so my view, if I was in any one of your portfolio company's shoes, is to not think of these in conventional terms. The easy part is this quick Copilot thing, which you should do, but really what you should be thinking about is what is the overall value creation thesis that I have, and to the first speaker's point, what problems have people not been able to solve in your domain for the last 5 years, 10 years, that you can now take a fresh look at? Sorry, elongated answer on that.
No, I think it's great. It relates back to, I think, a couple things that were mentioned earlier around, we're not really just talking about software market dollars. You're talking about the services
Exactly.
dollars, human capital dollars
Yeah.
expended, and depending on which market you're looking at, that's 5 to 20 times the size of the technology market.
Yeah, yeah,
And you're solving a broader problem.
exactly.
I'd love to come back to what you guys are doing on private cloud. I think this gets a lot into what Jay's talking about with Oracle and what, frankly, being a little late to the game allows you to see kind of where opportunities are unmet or things have evolved. It seems like you guys are very focused on, hey, there's an emerging set of needs that are very different for the enterprise, and your private cloud approach is attacking that. I'd love to hear a little more about that.
Yeah, so just to clarify there, when VMware was a standalone company, we were operating in what Jay called a multi-cloud. We were operating in public and private. Since Broadcom's philosophy is to narrow it down purely to private. And Broadcom is seeing, I'm still an advisor there, we are seeing a fairly tremendous amount of interest in this private AI product. And the reasons for that are threefold, and some of it was touched upon in the earlier conversations as well. One, like I said, in these large regulated industries, there is a significant amount of data on-prem that people don't want to take over to the public clouds as yet, or public language model providers as yet, to be more specific. Secondly, a lot of the high-value applications are still internal employee-facing, right? And thirdly, there is no way to formally verify correctness of an application, of a language model, right? And that is the reason why human in the loop is the only thing that works today. Because if you get an answer, there's no way to, in software, all of us that have grown up writing software know that there is formal ways of verification in software. That is why the software testing industry exists, right? Whereas here, or automated testing industry exists. Whereas here, there is no correctness at all. So no formal way to do software LLM correctness. So as a result of all of that, there is still a tremendous amount of interest in doing things internally. And the other misperception is that you need massive clusters, right, to do inference. What's happening in the enterprise is mostly post-training, right, and inference. And post-training could be simple things like fine-tuning or this technology called Ragh and so on, or it could be the newer ones like distillation and so on and so forth. But those are not super compute intensive.
Right.
And inference is not super compute intensive from needing widely distributed clusters or wide diameter clusters. It could be done within narrow clusters, if you will, right? As a result, these companies are able to deploy infrastructure and the business model such that for them, CapEx turns out to be a better ROI tool than OpEx. So if you saw some of the recent earnings announcements from HPE and Dell, they're all talking about massive pipelines of hardware going into their enterprises, right? Dell at one point said they have $3 billion worth of pipeline in their earnings call. So that's what's happening there. So there is a mini regeneration of compute infrastructure going into enterprises. So that's one. And then, like I said, the huge knowledge bases that exist in enterprises are still on-prem.
Yep.
And so that's why that's working.
Well, Raghu, thank you so much for the time.
Thank you.
Thanks for listening to Orbit, the HG podcast. If you'd like to find out more about HG and our work building enduring enterprises, subscribe to our newsletter at hgcapital.com/newsletters.